integration. I told you it's a very useful topic, examination point of view, as well as your future education is concerned. They are also everywhere in BSc or engineering. In each and every section there will be an integration. Okay, so you have to understand the basic proper integration. Actually, integration is the reverse process of differentiation, inverse operation of differentiation. It's also called antiderivative. The integration is called, another name for integration is antiderivative. Opposite of differentiation, antiderivative. For example, integration is the inverse process of differentiation. Integration is the inverse process of differentiation. For example, d by dx of sin x is equals to cos x. Therefore, integration symbol is like this. Differentiation symbol is d by dx. Integration symbol is, this is the integration symbol. Curve line is to be taken. Yes, almost yes. Integration of cos x. In integration, differentiation upon dx you are getting. Here it is into dx. Everything is inverse. Here division will come, here into. Okay. So therefore inverse means division and multiplication are the inverse operations. So here d upon dx is there, here into dx is there. So this is simply dx. Here dx indicates differentiation with respect to x. This function is to be differentiated with respect to x. Here this dx indicates integration with respect to x. So as in the same what it is technique. So in the differentiation, what technique is there? Here x is there, then only dx is there, then only x and x variable. This is the function of the variable x, and that one and this one is matching. Then only I can write down the integration formula. No, so differentiation formula. This is the function of the variable x, and that function of the variable x can be differentiated with respect to x only. Function of the variable x can be differentiated with respect to x only, then only you can write out the differentiation formula. Here also, this is the function which is to be integrated, that it is the function of x, and here also dx only. Okay, integration of cos x d theta is absolutely wrong. Here x, here is the what it is. Function of this function which is to be integrated is called integrand. It is called a what? Integrand. This is integrand. So the integrand is of the variable x. Then ಯಾವ function ಅನ್ನು integrate ಮಾಡಬೇಕು ಅದಕ್ಕೆ integrand ಅಂತ ಕರೀತೀಯ. The integrand is of the variable x, and here it should be not d theta, here it should be dx. Only the cos theta is compulsory d theta ಬರಬೇಕು. And the cos z ಇದರಲ್ಲಿ ಏನು ಬರಬೇಕು? dz. That's a differentiation. Here is the function of the variable x in upon dx. Here is the function of the variable t, dt ಬರಬೇಕು. Function of the variable y, dy ಬರಬೇಕು. ಇಲ್ಲ ಅಂದ್ರೆ chain rule ಯೂಸ್ ಮಾಡಿ ಮಾಡ್ಕೊಂಡಿದ್ವಿ. ಹೌದಾ? If it is y, it is x, then not possible. By using the chain rule, d by dy into dy by dx, we have differentiated the function. So variable matching should be there. So here into dx, coming back to the integration, therefore integration of cos x dx. This dx indicates simply integration with respect to x is equals to sin x. Is equals to sin x plus c. Well, I will tell you what I mean by this. C is a constant. Okay, c is a constant. It may be a numerical constant or any parametric constant like pi, etc. Okay, e, etc. Okay, c is called constant of integration. Why you are getting c? So because look here, c, where c is called, let us write down some basics of it, where c is called constant of integration. Constant of integration. Constant of integration, where c is C is any real number, where C is any real number. Okay, so any real number, even 0 maybe. Okay, why this C is taken? I will tell you. Because okay, this C is taken because of the following reason. C is taken because of the following reason. Following explanation or reason. Okay. What is d by dx of sin x? D by dx of sin x is equals to cos x. No? Therefore, integration is the reverse process. So, by differentiating sin x, you are getting cos x. Cos x is called differential coefficient. Sin x is called simply the function which is to be differentiated. By integrating the differential coefficient cos x, you are getting the original function. That is the meaning of reverse process. Sin x is the differential by the cos x. Cos x is the differential coefficient of sin x. Now, of the function, differential coefficient of the function sin x is cos x. By integrating this differential coefficient, we are getting the original function sin x. The cos x in sin x in differentiate cos x. The differential coefficient is cos x. By integrating cos x, you are getting the original function. So sin x. How do we d by dx of sin x plus cos is equals to cos x? Therefore, integration of cos x dx. The dx can extra because again differentiation upon dx into dx. Cos x. Actually, this is the function to be integrated. Cos x dx is sin x plus c. It is c out there upon there. C is 0. Here c is 0. C is sin x plus 0 on the differentiate. When they have differentiated sin x plus 0, therefore cos x I got. So d by dx of sin x plus 1 is sin x differentiation is cos x and 1 differentiation is 0. That is equals to cos x. That's equals to cos x. Sin x differentiation is cos x, 1 differentiation is 0. Therefore, integration of here also I got the same answer, cos x. Differential coefficient here also cos x, here also cos x. So integration of cos x dx is equals to sin x plus c. What is the c here? C is 1. Yes, c is equals to 1. D by dx of sin x plus k, where k is a constant, is equals to again cos x. Because sin x differentiation is cos x, k is constant, its differentiation is 0. Therefore, integration of cos x is equals to cos x dx is equals to sin x plus c. Here c is what? C is equals to k. Here c is equals to k. That's what. So, by differentiating sin x, you are getting cos x. Sin x plus any constant, then also you are getting the same differential coefficient cos x. The integration of the differential coefficient cos x is the original function sin x plus maybe any constant 0, 1, 2, 3. That's why c is taken. Understood? Where c is unknown here in integration, I can't get the value of c here. Therefore, this type of integration is called, where c value is unknown, is called indefinite integrals. Here, value of c cannot be determined. Here, value of c is unknown. It may be 1, it may be 0, it may be k like that. Okay. Here therefore, integration of sin x dx is, integration of cos x dx is, integration of cos x dx is sin x plus c. Sin x plus c. C, value of c is unknown here, value of c. Value of c is unknown. So I simply have the integration of cos x. So which function is actually differentiated? It is unknown. Whether sin x is differentiated, sin x plus 1 is differentiated, sin x plus k is differentiated, but for everything the differential coefficient is cos x. Therefore, which function differentiated unknown? Therefore, c is, I can't take it as k, or I can't take it as 1, I can't take it as 0. For value of c is unknown. Therefore, this integration is called indefinite integrals. C is indefinite. Value of c is indefinite. It may be k, or it may be 1, or it may be 0. Therefore, this differentiation is this integration. This integration is called indefinite integration. Is called indefinite integrals. Okay, indefinite integration. Indefinite integration. Okay, integration of some basics I am explaining. So, for example, one more example. For example, d by dx of x square is what? 2x. X square is what? 2x. When d by dx of x square plus 10 is also 2x. Therefore, coming back to the integration in the reverse process of differentiation, by integrating x square, differentiating x square, you are getting differential coefficient as 2x. Therefore, integration of 2x dx is equals to x square plus c is equals to x square plus c, where c may be any constant 0 or 1, x square plus 1 differentiation also 2x, x square plus 10 differentiation also 2x, x square plus pi is constant 2x. Therefore, integration by differentiating x square, we are getting differential coefficient as 2x. Therefore, integration of 2x, this dx is integration with respect to x. So, 2x dx is equals to x square plus c. Okay, where c is the constant of integration, it may be 0 or it may be 1, because d by dx of x square plus c, any constant c, x square plus constant c, x square plus 10, say I am putting 10, is also what? 2x. X square differentiation is 2x and 10 differentiation is 0. 2x plus 0 is 2x. Therefore, for this 2x also, integration is x square plus integration of 2x is x square plus 0. For this one, integration of 2x is x square plus 10, but whether it is 0, whether it is 10 is cannot be identified here, because here only 2x is there. Therefore, so it x in general it is x square plus c, c may be 0 like this, or c may be 10, etc. Okay. Second example. Now coming to the third example, integration of d by dx of log x. What is the log x differentiation? Is 1 by x. Therefore, integration formula is understood. You know the differentiation formula, then reverse of that one is the integration formula. Therefore, very simply, there is additional effort is not necessary to remember the integration formula. If you are very perfect in integration differentiation formula, there is no need of any additional effort to remember the integration formulas, because if you know the differentiation formula, the reverse of that one is the integration. Okay. Therefore, integration of 1 by x dx is equals to log x. Again, same thing plus c, because log x plus 1 differentiation is also 1 by x. Log x plus 10 differentiation is also 1 by x. Log x plus k differentiation is also 1 by x. Therefore, here comes c. The c may be 0 or c may be 1 or c may be any arbitrary constant k, like that. Okay. Fourth one, d by dx of sin inverse x. This is the basics of integration. Is equals to cos inverse x. Sin inverse x is 1 upon root of 1 minus x square. Therefore, integration of 1 upon root of 1 minus x square dx is equals to, it is sin inverse x plus c. So that is what it is, the basics of differentiation, integration. Integration is the inverse operation of differentiation. By differentiating a function, you are getting the differential coefficient. By integrating the differential coefficient, you are getting the original function. That's all. Okay. So, in general, d by dx of f of x is called d by dx of f of x is equals to f dash of x. No. Therefore, integration of f dash of x dx is equals to f of x plus c. Integration of, by differentiating f of x, you are getting f dash of x. Therefore, by integrating f dash of x dx, you are getting f of x. That is integration of d by dx of f of x, because f dash of x is taken as d by dx of f of x dx now, that's equals to f of x plus c. Is it not? F dash of x is d by dx of f of x. This dx can be cancelled. Therefore, that is, that is integration of d of f of x. This dx is simply cancelled, and d of f of x is equals to f of x plus c. So to remember this is the formula. When integration and differentiation of the inverse operations, just like sine inverse of sin x is equals to x, no? Both cancel. Similarly, integration and differentiation facing each other. Integration, differentiation. This is the integration. So integration and d facing each other, both cancels. What remains in front of d, that should be taken. Not only integration and d, even differentiation of d of integration of f of x dx. This d and integration cancels. That's equals to f of x answer f of x. Okay, integration and because sin inverse of sin x is also x. Similarly, sin of sin inverse x is also x. No, sin of sin inverse. Yes, sin inverse of sin. Both cancels. Sin of sin inverse, then also both cancels. Is x. No, like that. If differentiation, then integration of some function in there, both cancels each other, the answer is f of x. Similarly, integration and then differentiation of f of x, both cancels each other, and f of x remains. So, for example, so on this particular technique only, now you can integrate the function actually. Some function can be integrated on the basis of this particular technique only, integration of differentiation. For example, here, integration of x cube dx. So, I will introduce d then. Integration of x cube dx, integration of x cube is the d by dx of actually x raised to 4 upon 4. What is the x raised to 4 upon 4 differentiation? Okay, d by dx of x raised to 4. X cube is because d by dx of x raised to 4 upon 4, 1 by 4 constant outside, d by dx of x raised to 4, that's equals to 1 by 4, 4 into x raised to 4 minus 1, 3, 4, 4 cancels, that's equals to x cube now. Therefore, x cube is nothing but, by differentiating d by dx of x raised to 4 upon 4, I am getting 1 by 4 into d by dx of x raised to 4, constant is taken outside, x raised to 4 differentiation, 4x cube, 4, 4 cancels, d by dx of x cube remains, x cube remains, therefore d by dx of x raised to 4 upon 4 is x cube. Therefore, x cube is written as d by dx of x raised to 4 upon 4. Now, look here, d by dx of integration of f of x. Integration of d by dx of f of x is d by dx and integration cancels each other. Simply what remains cancels each other. The answer is x raised to 4 upon 4 plus the constant always is to be written. Now integration and differentiation of the inverse operation, just like sin of sin inverse x is x, or sin inverse of sin theta is theta, cancels each other. Therefore, x raised to 4 upon 4. Just like multiplication, 3 into multiplication 1 by 2, 4 cancels, multiplication and division cancels each other. Like that. So x raised to 4 upon 4 plus c. This is the one technique, but it is very difficult one. Okay. So this integration, the integrand, this is called integrand. The integrand is to be expressed in terms of d by dx of certain function. Very difficult one. Immediately it is difficult to, but it is. But one technique it is. Sometimes no formula suits, then this technique can be used in CET. So in what it is, 4 options will be given. Integration of some function will be asked, 4 options will be given. By differentiating those among those 4 options, which option gives the exact integrand. So this is the one technique. So 4 options, integration of x raised to 5 plus 3x squared plus 2x dx. 4 options will be there. So 1, A, B, C, D. Now we are going to differentiate each and every options. Which differentiation yields this much, that will be the answer. But time consuming one, because exactly first option is there, then you are lucky. Suppose the option is D, then A, B, C, D, one by one, 3 attempts, failure attempts, 4th will be successful. That's why time consuming one. But one technique you have to remember, sometimes if you are not getting which formula is to be applied for the integration, then this technique in CET will serve the purpose, but it is a time consuming one. Okay. If one more example, if f dash of x is equals to 1 upon 1 plus x square, okay, f dash of x is equals to 1 upon 1 plus x square, it is or 2 upon 1 plus x square, find f of x. Find f of x. So, actually, integration of f dash of x is equals to f of x. Okay, f of x is equals to integration of f dash of x dx. Here it comes. Integration of f dash of x is equals to f of x plus c. Okay, f of x plus c. Integration of f dash of x plus c is equals to what it is? F dash of x dx is equals to f of x plus c. F of x plus c is equals to integration of f dash of x dx. Okay, therefore integration of what is the f dash of x here? 2 upon 2 plus x square dx. But express 2 upon 1 plus x square in terms of d by dx. It is so 2 is taken outside. Constant can be taken outside the integration, just like in differentiation. Constant can be taken outside the differentiation. It is d by dx of what it is? Tan inverse x. No, tan inverse x different. So it is 1 upon 1 plus x square. Constant can be taken outside the differentiation. 2 into integration of 1 upon 1 plus x square dx. What is 1 upon 1 plus x square? The differentiation of tan inverse x. No, it is d by dx of tan inverse x. Tan inverse x differentiation is 1 upon 1 plus x square. Therefore, it is equals to f dash of x plus c. F dash of x plus c is equals to integration and differentiation cancels. It is equals to tan inverse x. Tan inverse x. No, it is tan inverse x plus c. Integration. Again, once integration is over, you have to put 1c. Okay, you have to put 1c. Therefore, so for that integration, you have to put 1c. Therefore, c cancels here. Therefore, f dash of x is equals to tan x. F dash of x is equals to tan inverse x. Okay, now f dash of x is equals to tan inverse x. c cancels, that is answer. So, but these are all what is integration. For that one, these formulas are taken. Actually, these discussions are taken. This is what it is, very difficult procedure just to understand what is integration. These things are explained, but integrating the function by these techniques are actually a time consuming one, and it is not possible in all cases also. Therefore, list of formulas are there. Just like in differentiation, list of formulas are there. In integration also, there is a list of formula. By using the list of formula, we can differentiate any function. But we can integrate any function. But one thing is, all functions are differentiable. Any function you take, it is differentiable. But all functions are not integrable. There is no formula to integrate each and every function. Just remember, there is the one, what it is, technical point. Any function is there, I can differentiate it if it is differentiable. Okay, but all functions cannot be integrated using the list of formula. I can't integrate all functions. Okay, only certain functions. So where it is matching with the integration formula can be integrated. So simply integrate x square plus 2x plus 3 divided by x plus 5. Not possible. A random function, but differentiation of any function is possible. Okay. So only certain set of functions can be integrated, not all. Okay. Therefore, f dash of x dx, coming back to the basics. Therefore, if integration of integration of f of x dx, suppose by integrating f of x, you are getting pi of x plus c. Pi of x x plus c. By integrating f of x, we are getting a function pi of x. Say answer is okay, pi of x. Here f of x is called integrand. The function which is to be integrated is called integrand. Here f of x is called integrand. Which function you are integrating, that's called integrand. Okay, f of x is called integrand. Pi of x is called integral. The answer is called integral. Is called just like in differentiation. The answer is differential coefficient. Here it is integral. Pi of x is called integral. And c is called constant of integration. C is called constant of integration. Constant of integration. C is called constant of integration. Its value is unknown. Its value is unknown. Therefore, this integration is called indefinite integrals. Its value is unknown. Its value is unknown. The process of getting integrals for a given integrand is called integration. Getting pi of x from f of x is called integration. The process of getting this is integrals, this is the integrand. The process of getting integrals for a given integrand is called integration. Is called integration. This process is called integration. Okay. Dx indicates this here. Dx indicates integration with respect to x. This function is not, dx is not to be integrated actually. Dx indicates integration with respect to x. Dx indicates integration with respect to the variable x. Integration is with respect to x. Integration is with WRT with respect to x. Integration of s, if the integrand is of a certain variable, then the integration should be with respect to that variable only. Okay. Integration of f of dx. Integration of so here it is f of x dx means f of x means here dx should be there. Here f of theta is there means here d theta should be there. Here f of z is there, here dz should be there. F of t is there, here dt should be there. Okay. The integrand of a certain function can be integrated with respect to that function only. Okay. So any more point to be explained in integration? Okay. This only these many. So for example, one more example, let us take integration of dx. Only dx is there. That's equals to, for example, it equals to integration no dx. Okay. So by the previous discussion, one can give the answer. Integration in d cancels, therefore the answer is x. Okay. One formula is given, integration of d of f of x is f of x. Here also integration in d cancels, answer is x. Otherwise, the 1 dx, I can write 1 dx as 1 into dx. 1 into dx is dx below. Now, 1 is nothing but integration of d by dx of x. D by dx of x is no, therefore dx. Now, integration and differentiation cancel, the answer is x plus c. Okay. So, for integration of simply dx is there, that's equal to integration of dx is x plus c. Okay. Well, here only. Integration, here only I can write down the answer. Integration and d with differentiation cancels each other, 1 means x. And for the formula integration of d of f of x is equals to f of x. Integration of dd cancels, x means okay, short. That's the basics of differential integration. I will give the list of formula of integration tomorrow and then straight away integration problems. On the basis of formula only you can integrate. These techniques